All right, so 6.3, we start talking about vectors. And if you read that definition, basically a vector is a directed line segment. It has both magnitude, kind of the strength of the line or the vector, which is the length, and it gives direction. So kind of using our unit circle, we can end up with vectors pointing anywhere from 0 all the way around the unit circle to 360 degrees. We can also name these things with just a lowercase u, v, or w. So first of all, we are going to graph this vector initial point, which is a fancy way to say start, and terminal, end. So graph those 2 points. If you do that, you'll get something that looks like this. You'll get a line that's right there, and if you kind of draw an arrow on this end, the arrow would be over here. So start, end. And then it starts talking about vectors can be written in what is called component form. And component form, they will put brackets, these angled brackets, around the x and the y, if you will. These things right here. And so P to Q, if you're going to find the component form, you do terminal minus initial. And so when you are looking for the component form vector down here, negative 3, 2, and 5, 8. The initial is negative 3, 2, and the terminal is 5, 8. So if I was going to look for vector v, I would do the terminal x, which is 5, minus negative 3, and then I would do 8, which is the terminal y, minus the 2. And so what I end up with is 8, comma 6, and I use those, kind of looks like a 67. I use those angled brackets to indicate component form. So now if I graph one at 8, 6, we can come back over to this graph, and basically what I would have is if I take this one and I go down 2 and over 3, so notice how I moved. I'll do that again. So watch right here, the initial point. I go down 2 and over 3. Well, if you look at the arrow tip, go down 1, 2, 3, over, 1, 2, 3, what happened here? Oh, down 2, we're only going down 2. So down 2 to the right, 1, 2, 3. My arrow tip now ends up over here at 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 to the right and up 1, 2, 3, 4, 5, 6. So it ends up in the same spot when I calculated it using the map. So you can do a manual. You can literally pick up the line and move it. But the key now is that the origin, right, the initial part, I should say, the initial is at 0, 0. So that's the key. So what this means is this is the terminal here now, and we know the initial is sitting at 0, 0. So what this allows us to do is a little easier way to find magnitude, because if you find magnitude, you use the distance formula. Well, this number would be 8, and this would be 0, and this would be 6, and this would be 0, which is the same as just taking 8 squared plus 6 squared. So if it's in component form, you just have to do the x and y squared, add them together under the radical. Okay, so now if my 8 comma 6 is our component form vector, now they want us to find the magnitude, and we put double bars around the v, and I simply take the square root of 8 squared plus 6 squared, and I end up with 64 plus 36 is equal to the square root of 100, which is 10. A unit vector just means that it has magnitude that is exactly 1. And so if you take your vector, 8, 6, and you put it over the magnitude, you can do 8 over 10, 6 over 10, and if we reduce properly, we get 4/5, comma 3/5. And I can show you on the calculator that if I take the square root, and in parentheses I put 4/5 squared plus 3/5 squared, it's all under the radical, and so when I do that I get a 1. And so this has magnitude equal to 1, which is what we want. So I found a unit vector right there. So now, sorry about that. So now when we talk about what is called a standard unit vector, I have 8, 6. If we do a linear combination, the I stands for the horizontal component. So I would do 8i plus 6j, and so that would be your standard form vector. So remember our vector is 8, 6, and so I think it's best to always draw the diagram, and we're going to the right 8, up 6, so to the right 8, up 6, kind of the same triangle that we've been doing all along. And if we want to find theta, the easiest is to just do the tangent. Opposite over adjacent, and you do the inverse tangent on both sides. And so on a calculator, if you do the inverse tangent of 6 divided by 8, it'll tell us that we're about 36.87 degrees.